Good morning, students. Chapter 6, Work, Energy and Power. Yes, in last lecture we have discussed about some questions based on elastic collision in two dimension. Okay, now we will see one more question which is based on elastic collision in two dimension. See, a ball moving with a velocity of 12 meter per second collides with another identical stationary ball. After collision, they move in xy plane as shown in figure. Find speeds of balls after collision. Also decide whether the collision is elastic or not. See, you are given this figure, and for this figure, you have to find speeds of balls after collision. See here, a ball moving with a velocity of 12 meter per second collides with another identical stationary ball. Identical balls. So I have to assume let m1 is equal to m2 is equal to m. Their masses are same because they are identical. Okay. Now a ball moving with a velocity of 12 meter per second collides with another identical stationary ball. So this ball is moving with velocity 12 meter per second and it is stationary. So yes, what is data? U1 is equal to, it is 12 meter per second and U2 is equal to, it is 0. U2 is equal to, it is 0. Clear about this? Yes. U1 is equal to, it is 12 meter per second and U2 is equal to 0. You have to find speeds of balls after collision. I am assuming that speed of this ball after collision is v1 and speed of this ball after collision is v2. Okay, let speeds of balls after collision are v1 and v1 and v2. So yes, we have to find v1 and v2. How to find this v1 and v2? Yes, see, it is, you have to find, also decide whether the collision is elastic or not. So we don't know it is elastic collision or not. So we cannot use law of conservation of kinetic energy. So obviously we have to use law of conservation of linear momentum. Okay, law of conservation of momentum. Law of conservation of momentum. See, law of conservation of momentum. It is, this situation is before collision. This situation is before collision. Okay, and this situation is after. This situation is after collision. Okay, so yes, before situation and after situation you are given figure. So now yes, you have to apply. Yes, you have to apply law of conservation of momentum. See, object A having mass m is moving with velocity u1. So it is m u1. Clear about this? Clear about this? It is m u1. B is stationary, so its momentum is 0. Is equal to this this object A, again its mass is m, is moving with velocity v1. So after collision its momentum is m v1, plus this ball B having mass m is moving with velocity v2 in this direction. So yes, it is let m v2. Clear about this? So yes, how to write this equation? mv1 plus 0 is equal to mv1 plus mv2. Now we will take components of this equation. For that, see, this u1, it is in x direction only. You have to resolve this v1 and v2 into components like we have resolved in last question or in last theory. Okay, so see, first of all you have to resolve this v1 into components. How to resolve this v1 into components? Like this. See, first component, second component. As this angle is 30, obviously this angle will become 30. So yes, v1 is making angle 30 with this component, so it is called v1 cos 30 and it is called v1 sin 30. Clear about this? Similarly, I will resolve this V2 in two components. First component in this direction, okay, in this direction, and another component in this direction. Again, as this angle is 30, this angle will become 30. V2 is making angle 30 with this component, so it is called V2 cos 30, and it is called V2 sin 30. Clear about this? So yes, U1 it is along x-axis, but V1 and V2 they are not along x-axis, so you have to resolve. So you have to resolve V1 and V2. So yes, you have to resolve V1 and V2. Clear about this? So yes, we have resolved V1 and V2 as shown in figure. Now, according to law of conservation of momentum, we have this equation. Now, take x component of this equation. Take x component. Take x component of this equation. See, here it is m. U1 is along x-axis. U1 is along x-axis. Yes or no? U1 is along x-axis. So yes, its velocity is in x direction, so it has only x component, and that is u1. Plus, here it is 0. M. What is x component of v1? It is v1 cos 30. It is v1 cos 30. Plus m. What is x component of v2? It is v2 cos 30. It is v2 cos 30. Clear about this? It is v2 cos 30. See, this v1 cos 30 and v2 cos 30, they are in same direction, so there is plus sign between them. This v1 cos 30 and v2 cos 30, they are in same direction, so there is plus sign between them. Any doubt? Now, this m, and m cancel. Yes or no? Yes or no? So yes, here I can write this u1 is equal to v1 cos 30 plus v2 cos 30. So yes, I can also write u1 is equal to, it is v1 plus v2 cos 30 common, cos 30 common. Clear about this? Clear about this? And yes, what is value of cos 30? Cos 30, that is 3 by 2. Cos 30, okay, cos 30, that is root 3 by 2. So u1 is equal to, it is v1 plus v2. Here it is root 3 by 2. And yes, what is value of u1? What is value of u1? U1 you are given, it is 12 meter per second. It is 12 meter per second. So if I want to make v1 plus v2 as subject, then v1 plus v2 is equal to, v1 plus v2 is equal to, it is 2 this side, so it is 24 divided by root 3. That is equation number 1. That is equation number 1. Clear about this? It is like equation number 1. Now, we have to find v1 and v2, but we have only one equation. So according to maths, you have to obtain another equation. You have to obtain another equation. How to obtain another equation? Yes, we have considered only x. Now, how to take y component? See, we will take y component of equation. Y component of equation. Yes, m. u1, it is already in x-axis, so its y component is 0. Second object is stationary, so its momentum is 0. Is equal to, in figure, v1 sin 30 is in upward direction, so it is m v1 sin 30. While v2 sin 30 is in downward direction, so it is minus m v2 sin 30. Clear about this? Now if I take this term, this side, I will have this m v2 sin 30 is equal to m v1, here it is sin 30, m cut, sin 30 cut, sin 30 cut. So v2 is equal to v1, equation number 1. So equation number 2. What is equation number 1? That is v1 plus v2. It is 24 upon root 3. So in this equation I can put v2 is equal to v1. Then yes, I will have v1 plus v1, 24 upon root 3. Means 2v1 is equal to 24 upon root 3 is equal to v1, it is 12 upon root 3 is equal to, it is 4 root 3. v1 is equal to, it is 4 root 3. And hence v1 is equal to v2. v1 is equal to v2 4 root 3 meter per second. So it is your first answer. It is your first answer. Clear about this? Why minus is here? Because V1 sin 30 is in upward direction, V2 sin 30 is in downward direction. Clear about this? Now V1 is equal to V2 is equal to 4 root 3. We have to check if it is elastic collision or not. So we have to find what is total initial kinetic energy. Total initial kinetic energy, that is Ki. That is Ki. Only object A is moving, half m, its speed is 12 square, plus second object is stationary. Second object is stationary. So here it is 12 square 144 divided by 2, it is 70. It is 72 mj. M, that is mass, because we are not given mass. Okay. Okay. Now how to find total final kinetic energy? Total final kinetic energy. Total final kinetic energy Kf is equal to half m. What is speed of first object? That is V1. It is 4 root 3 whole square, plus half m of second. It is also 4 root 3 whole square. Clear about this? It is before. Only object A is moving with speed 12. Object A is stationary. After collision, they both are moving with same speed, that is 4 to 3 meter per second. Is equal to half m. 4 square 16. Root 3 square 3. So 16 into 3 is 48. Similarly here, half m. Here it is 48. So your answer is it is 48 m. So see, what is total initial kinetic energy? 72 m. Total final kinetic energy 48 m. Here Ki is not Kf. Total kinetic energy is not equal to total final energy. So collision is not elastic. Collision is not elastic. Clear about this? So yes, in this question you have to find two questions: speeds after collision and whether this collision is kinetic or not. How to find collision is elastic or not? You have to find total energy before collision, after collision. If they are same, it is. If they are same, it is elastic collision. If they are not, it is not elastic collision. Clear about this? Easy. Okay. Now next question, which is based on law of conservation of energy. See, a tube is fixed in a vertical plane as shown in figure. From point A, a sphere of mass 0.314 kg is released. During its motion in the tube, it faces a constant resistive force R. At B, its velocity becomes 0. Calculate the constant resistive force R and work done by resistive force. Average radius of tube is 1 meter. See what is question here. You are given this, a tube, okay, which is placed in vertical plane. From this point A, a sphere is dropped. Now, when sphere is moving in this tube, it faces constant resistive force. So yes, due to that constant resistive force, its energy decreases. Yes or no? And at point B, you are given, okay, it's yes. At point B, its velocity becomes 0. You have to find the constant resistive force and what is work done by resistive force. You are given radius, that is R. Yes, here from O to A, it is radius R. Okay, so see here, this OA, this OD, this OB, radius, yes or no? So here from figure, I can write from figure, OA is equal to OD is equal to OB is equal to nothing but radius. Yes or no? Yes. This angle you are given, it is pi by 3. Now what will we do? Here we have to use law of conservation of energy. We have to use law of conservation of energy. How? See here it is. First of all, I am taking reference surface passing from B. I am taking reference surface passing passing from D. Okay, take reference surface, take reference surface passing from D, okay, or from lowest point. So yes, we have to calculate each and every height from this surface. Yes or no? Yes, it is. Now I will find total energy at point A. At point A, total energy. EA is equal to, yes, simple question, EA is equal to kinetic energy plus potential energy. Yes or no? But see here, this one, a sphere of mass 0.314 kg is released from point A. From point A, a sphere is released. It's released. Release means it is dropped. Okay, so its initial speed is 0. So its kinetic energy is 0. Clear about this? Plus UA, potential energy at point A. Potential energy at point A. See here, OD, it is R. OD, it is R. It is nothing but radius. So this point A is at height R from this reference surface. So yes, its potential energy, it is mgr. So yes, this first equation, that is EA is equal to, it is mgr. Equation number 1. Clear about this? Now, during its motion in the fluid, it faces a constant resistive force R. At P, its velocity becomes 0. So final point is P. So now at point B, total energy at point B, total energy. See how to find at point B total energy. Again, EB is equal to KB plus UB. Yes or no? That is kinetic energy plus potential energy. Yes, kinetic energy plus potential energy. Again, see here it is. At B, its velocity becomes 0. At B, its velocity becomes 0. So its kinetic energy, yes, it is 0. Plus, what about potential energy? Potential energy means mgh. So yes, it is mg. But what about h? Yes, from this reference surface, B, it is at this height. So yes, you have to find this height. You have to find this height. For example, let it is point B dash. Let it is point B dash. Yes or no? So yes, this point B is at height B dash D from this reference surface. So here you have to write it is B dash D. Clear about this? See, for point A it is easy from figure. If from this reference surface, point A is at height R, that is equal to radius. But this point B, so first of all you have to calculate this distance B dash D. How to calculate this distance B dash D? How to calculate this distance B dash D? See, here it is. See, here it is. You have one triangle. See, observe. O B dash B. Triangle O B dash B. Yes or no? Yes, it is right angle triangle. It is pi by 3. Yes or no? OB dash, it is its adjacent side, and OB, it is hypotenuse. Yes or no? So which trigonometric function you have to consider, sine, cos or tan? Yes, for pi by 3 it is adjacent side and it is hypotenuse. So obviously it is cos. Obviously it is cos. So cos pi by 3 is equal to OB dash upon OB. Cos pi by 3 means cos 60, and cos 60, that is 1 by 2. So just here it is 1 by 2 is equal to OB dash. I have to find OB dash. Okay. OB is nothing but radius, so it is R. So what is OB dash? OB dash is equal to R by 2. OB dash is equal to R by 2. So see from figure, if this OB dash is equal to R by 2, B dash D is also R by 2. Yes or no? Because B dash D is equal to OD minus OB dash. OD, what is OD? It is R, and here it is R by 2. So yes, here it is R by 2. So what is B dash D? It is R by 2. So yes, is equal to, it is 0 mg. What is B dash D? It is R by 2. So EB is equal to mgr by 2. EB is equal to, it is mgr by 2. What is EA? mgr. At this point, what is total energy? mgr. At this point, what is total energy? mgr by 2 means half. Then where is another half energy? Where is another half energy? Yes, it is used. It is used against resistive force as a work done. It is used as work done against resistive force. It is used as work done against resistive force. Do you understand this step? Okay. Yes, at point A total energy is mgr. At point B total energy is mgr by 2 means totally half. Then where is remaining energy? That remaining energy is used as work against resistive force. So now we will find. Okay, what is energy used against resistive force? Okay, work done against resistive force. How to find this? See, WR is equal to work done. It is resistance into distance. Okay, so it is force. Force is given R. Yes, you are given constant resistive force R. So yes, here it is R. Now what is displacement? See, initial position is A and final position is B. Initial position is A and final position is B. So see, this AB arc makes some angle with this center. How to find? See, this AB makes some angle with this AB makes angle with center. See, what is angle? Here it is. It is A. Here it is B. This angle is pi by 3. We know that. What is this angle? It is pi by 2. So what is total angle? Total angle is, it is pi by 2 plus pi by 3 is equal to, it is 3 pi plus 2 pi. So it is 5 pi by 6. Here it is 5 pi by 6. Yes or no? Here it is 5 pi by 6. We have to find this distance. This R. And how to find R? Yes, we have one equation. Angle is equal to arc upon radius. So arc is equal to angle into radius. So yes, arc is equal to angle. It is 5 pi by 6. And what is radius? Yes, radius is r. Clear about this? So yes, you have to find this distance. And that distance is, this r is equal to 5 pi by 6 into r. Again, initial position is A, final position is B. A and B. So this AB subtends an angle of pi by 2 plus pi by 3, that is 5 pi by 6 with center O. So according to this definition, angle is equal to arc upon radius. Arc is equal to angle into radius. So arc is equal to this 5 pi by 6 into arc. So yes, this arc is equal to, now here, work done against resistive force WR is equal to arc into 5 pi by 6 into arc. 5 pi by 6 into, clear about this? So yes, now you have three equations: energy at EA, energy at B, energy or work done against resistive force. Now what is relation between them? Simple. Initially object is at point A having some energy. Its energy is used, and then it reaches to point B. So at point B it has remaining energy. Then how to write according to law of conservation of energy? According to law of conservation of energy. How to write? EA. Okay, initially it is at point A. So at this point it has energy EA. Now some energy is used against resistive force. That is WR. and plus at point B it has remaining energy, that is E. That is E. Clear about this? Okay, so yes, it is relation. So yes, it is relation. Now here EA mgr is equal to WR. What is WR? WR is R into 5 pi by 6 into R plus what is EB? It is mgr by 2. It is mgr by 2. Clear about this? Okay, yes. So R into 5 pi by 6 R is equal to mgr minus mgr by 2. mgr minus mgr by 2. So yes, it is obviously mgr by 2. It is mgr by. Clear about this? Now make this R as subject. This R cut, this R cut. That's not moving. R as subject. Then R is equal to, it is 6 mg upon 2 into 5. 2 into 5. Okay, so yes, here it is 2 into 3. So here it is 3 mg upon 5. It is 3 mg upon 5. Yes, you are given each and every value. So yes, it is 3 into what is value of mass? It is 0.314. It is 0.314. Value of G, that is 9.8, 5, that is 5, and it is 3.14. If you calculate this, you will get value of R to be 0.6 Newton. 0.6 Newton. And now second question is, you have to find work done by resistive force. So work done by resistive force's equation is R into 5 pi by 6 into R. So here it is 0.6 into 5 into 3.14 divided by 6, and here it is into 1. And here it is into 1. Clear about this? So yes, with the help of this equation, you can easily find what is work done against resistive force. What is work done against resistive force? And if you calculate, you will get this answer 1.57. It is 1.57. Clear about this? So yes, again it is one question which is based on law of conservation of energy. Clear about this? Again, work, energy, power. This chapter is important because in this chapter you have to apply two most important laws, that is law of conservation of momentum and law of conservation of energy. Clear about this? Okay, so yes students, watch our videos regularly. You have to make your notes, send any doubts if you have. I will try to solve your doubts. And yes, regularly do like, share, comment our videos.